So best case scenario, when is the expectation timeline-wise that you guys will start carrying up tourists on a regular basis? Every other week, every other month. Best case scenario.
Uh, we'll take a quick shot at it. It's first of all, our focus right now is flying not necessarily the tourist market, but flying NASA astronauts to the space station, fulfilling that need, and that's what we're getting paid to do by NASA. So this funding they're giving, the funding that we're getting from NASA is not intended to take tourists for a ride. So that's the first part of it. But eventually, once the capability exists, certainly there are other markets, and to address that, I'll turn it over to Kirsten.
So our long-term goal, Elon's long-term goal as he founded the company, is to make space travel more accessible to everybody. So, one of the things that we're trying to do, and it's a long-term goal because everybody else says it's impossible, or a lot of people do, is we want to make our whole system reusable. Right now, a rocket goes up, spacecraft takes off, the rocket is gone for liquid-fueled rockets like we have. We want to do everything we can to make it more affordable, safer, and more reliable, so that long term we can make space transportation more accessible. I would say any answer we gave you would be aspirational. We hope soon, but we're going to do the most we can do.
What kind of reaction have we gotten from the Russians on this project?
Well, nothing directly because we don't work with the Russians. They're not our customer. There was some. All I could share with you is what I read in the press, because they don't talk to us and we don't talk to them. But in the press, they were complaining a little bit about having a say about the Dragon coming to the space station. Our response was we're meeting every single one of NASA's safety requirements, performance requirements. If the Russians have an issue with how NASA set their safety requirements, they need to talk. But that's really an issue between Roscosmos and NASA. We don't play in that. But when people are asking about competition, I'll just expand a little bit on that. About the MPCV, and we don't view a competition there, but we do view, to a certain extent, competition with the Soyuz. Because once the shuttle stops flying, hopefully Friday will be a good launch, but it will be the last launch. And after that, the only way for NASA astronauts to get to the space station is on the Soyuz. The price of that keeps going up. It's the last bill we got was $63 million a seat. So that's our competition, and that's what we hope to do is stop paying $63 million of U.S. taxpayer money to the Russians for a seat, and instead spend it on getting the Dragon ready to go.
And when will you be ready to do that?
We think 3 years. Technically, as far as if we get full support from NASA, we can be ready to go 3 years from now.
And your competition?
That's a question for them.
Well,
we want to be close.
Seasoned, yes. On the structure and design, why did SpaceX go with a capsule format instead of something derived from the lifting body technology or structures similar to the
capsules are again, a lot of our safety. It's difficult to be cost effective and safe if you try to do everything, right? And that's a lesson kind of learned from the shuttle. The shuttle does everything. It's a magnificent vehicle, but to do everything is very complicated, and that complexity adds a lot of cost. It costs $200 million a month to fly a shuttle. From a blank piece of paper to the first flight, it costs $300 million to design the Falcon 9. So just for comparison's sake. So complexity adds cost. It also reduces safety. In order to meet all the requirements and to do everything for everyone, the shuttle you had to make the design decision to mount the shuttle on the side of the tank. And that was a direct contributor to what happened to Columbia, and an indirect contributor to the disaster of Challenger as well. So you operate closer to the edges of the envelope when you try to do everything. The decision to go with a capsule instead was made because that allows you to be cost effective at the same time safer. The capsule, and the Soyuz is a good example of how robust a capsule can be. You can have major failures. When I was on the space station, my commander, Peggy Whitson, came home with her crew on the Soyuz. I waved goodbye. I took a picture of her out the window. And they had a major problem a couple hours later when they were re-entering. One of the bolts didn't fire. and separate. Two of the modules were stuck together that were supposed to separate when they entered the air. And that thing started really heating up. A winged vehicle would have been doomed. But the capsule was so robust that eventually the heat of reentry kind of melted away the interface, and the capsule was robust enough to right itself up, and with its inherent stability, survive. And Peggy is now the chief of the astronaut office, and I got to hang out with her when I got back, which was really nice. So you can see that a capsule it just allows you to do that. It allows you to have a simpler design, which is cost effective and safe.
Will you go into space again?
Possibly. I'm not ruling anything out or anything, and that's not why I took this job. Peggy was nice enough to tell me that she'd be happy to let me fly again. I didn't break anything real expensive the first 2 times I was up there, so she was happy to let me have another crack. So if my goal was to fly in space, I should have probably stayed where I was. But I chose to do this because I viewed it as the greater challenge and also the opportunity to do greater good.
That brings up the question then, have you guys already hired experimental test pilots?
We have one working for us. It's my boss, Ken Barasox, who's a former shuttle commander and former Navy test pilot. But no, we're not. We still have to work out exactly. We're still years away from coming up with the actual test plan and figuring out what we need in the crew. And for that matter, if the crew is going to be a SpaceX crew, or is it going to be a NASA crew, or is it going to be some kind of joint test team like is often done for military aircraft? So the answer is no.
But so there is time to get your training and apply.
That's right.
What do you need? What will you accept as
Awesome. When you ask Elon Musk what he looks for in a candidate, he says awesome.
That's a good answer.
Well, you look at the what the Mercury 7 had to go through, and sitting over at the visitor center today, like I couldn't fit in the Gemini or the Mercury capsules because you had to be under 5'10" and do all these crazy, ridiculous tests which were depicted in The Right Stuff. Just curious, going off this question, like, what do you need a X number of flight hours or?
Well, first of all, let me say that our intention when we design the interior of the Dragon is to be able to fit the current size range of the astronaut office in factory and to meet the anthropomorphic requirements that NASA gives us. So that means that you don't have to be as short as me to ride. And
if you ask our engineers how many astronauts could it carry, they'll say, well, 9 really little ones.
Right. But NASA has
NASA
their own requirements. They're not going to tell their bigger guys, sorry, you got to find new work. So we got to find a way to make it work for even some of the biggest people that get inside. So that's first. And then as far as the requirements, for basically our customers predominantly will be NASA astronauts. So really, it will be their training and their experience that we'll be leveraging as far as crew members go.
Follow up, just wondering, since you have Richard Branson, who bought out the rights to the forget the name of it, but the one spacecraft Spaceship One that won the X Prize. Do you view? So you really don't view them at being in the commercial sector as any real competition?
They're really doing something completely different from what we're trying to do. So their vehicle is a suborbital vehicle, so there's no way you can get to the space station with their vehicle. It goes up and it comes down, so that is something that the Dragon is designed to be orbital, so it can get into orbit and then catch up and rendezvous and dock with the space station. And secondly, they're targeting that tourist market. So they're charging people for rides, and that's really what they're all about. What we're trying to do is really provide a vehicle for professionals going to the space station. Yep.
How does the processing power that we have now change what we're able to do versus what Apollo could do back then?
Yeah, boy, the avionics are probably the biggest difference between now and then. And so that allows you to do a lot of things. First of all, it allows a much better crew interface. You can have much better displays. You can have, you know, like even compared to the shuttle, you can have color graphical displays as opposed to monochromatic text. You know, it's really quite nice. You can have a moving map. You know, it's really cool stuff like that. And you can even, we guys in the backseat can play video games. So yeah, processing power. Obviously, what that also allows you to do is operate with a smaller mass and power budget and still get the same job done. So that's a big advantage. And it allows for much greater automation. The shuttle, even the shuttle, you don't have to go back as far as Apollo to see the limits of processing power and the impact on operations in spacecraft. If you look at the shuttle, it's very little automation. It relies on a tremendous amount of redundancy to deal with failures, but anything beyond a single failure, it has no ability to reconfigure the systems to protect for the next failure. And that's really the crew's job in the space shuttle, is on the flight deck. It's not doing anything for that first failure. It's reconfiguring the system to optimize to protect against the next failure. That's really pretty much all of our procedures are geared towards that. Your car does that, okay, by itself automatically. If you have a failure of a certain sensor in your fuel injection, like say that PPO2 sensor, it has backup algorithms that uses other sensors to set the timing on your car. It's smart enough to do that. It's more advanced in that regard than the space shuttle. So that's the big difference in processing power.
Going off of that, you were talking about multiple redundancies in the system for safety. How many of those are software, and then how many of those are hardware? Not saying that you're running like, you know, Windows.
Well, the redundancy comes from multiple processors. We have 3 flight computers, each running their own. Most of the software, safety in the software comes from brakes. The nice thing about software is you can test the heck out of it. So much of your safety comes from that.